But when this titan needs to stop, it relies on a single piece of engineering to hold it against the fury of the sea.
It is a floating city. 100,000 tons of American diplomacy, patrolling the world's oceans.
The anchor chain. A chain where a single link weighs as much as a motorcycle. The journey begins here, in the heart of the American industrial Rust Belt.
We start with special-grade alloy steel, high carbon, manganese, and nickel, formulated for extreme tensile strength.
These bars are 4 inches thick, cold, hard, and unyielding. The hydraulic shear applies 2,000 tons of force, slicing the solid steel in a fraction of a second. To build the chain, we must first cut the raw stock into precise lengths. Foreman Jack checks the length. If it's off by a 1/4 inch, the link won't form a perfect oval. These steel logs are the building blocks, but right now, they are cold and brittle. The bars pass through electric induction coils. Magnetic fields agitate the molecules, generating heat from within.
To bend them, we need heat, a lot of it. In 90 seconds, the steel reaches 1,800 degrees Fahrenheit. It is now in a plastic state.
It emerges as a glowing rod of potential energy, ready for the bending machine. The hot bar is positioned against a central mandrel. This pin defines the inner diameter of the link. This is where the magic happens, the birth of the link. Hydraulic arms, powered by immense pressure, wrap the steel around the pin like it's made of rubber.
It's a delicate dance of brute force. The steel screams silently as it is forced into a perfect loop.
The machine threads the new hot link through the cold finished link before it. Now we must close the gap. The ends must become one solid piece of metal.
This continuous cycle, heat, bend, thread, is what builds the lifeline of the ship.
Enter the flash butt welder, a machine that uses electricity to fuse metal at the atomic level.
But a loop is not a chain. It needs to be connected to the previous link.
At the moment of peak heat, the machine slams the ends together with 50 tons of force.
The 2 ends are gone. There is only one continuous ring of steel. 50,000 amps of current surge through the gap. The steel literally explodes into a liquid state.
While it's still hot, a trimmer shaves off the excess flash, leaving a smooth, seamless joint.
The weld is now actually stronger than the base metal itself.
But for a Navy chain, a simple loop isn't enough. It needs a backbone. The stud is pressed into the center of the cooling link. As the link shrinks, it locks the stud in place forever. We insert the stud, a center crossbar that prevents the chain from tangling under tension. Link by link, the chain grows to a length of 1,000 feet.
But the steel structure is currently stressed from the welding. It is too brittle for the sea.
It needs heat treatment. The entire chain is lowered into a normalizing furnace. It bakes at 1,600 degrees for 4 hours. This relaxes the internal grains of the steel. Then, the shock. Quenching. The hot steel is plunged into a water bath. The rapid cooling freezes the molecular structure into a hardened state. It emerges tempered, tough on the inside, hard on the outside.
This process, called quenching, doubles the hardness of the steel surface.
Now we have a chain. But will it hold an aircraft carrier in a hurricane?
Every single section of Navy chain must be proof tested. This machine is designed to simulate the pull of a 100,000-ton ship drifting in a storm.
The tension builds. 500,000 pounds. 700,000 pounds.
We pull it to 1.5 million pounds of force. If a link breaks here, the whole chain is rejected.
It holds. The chain has proven its worth. The chain moves through a shot blaster. High-velocity grit strips away the furnace scale and rust.
We don't use brushes, we dip.
The chain is submerged in a specialized bituminous coating. Thick, sticky, and waterproof.
It comes out clean, bare metal, a perfect surface for painting.
This black skin will protect the steel from the corrosive salt of the ocean for decades.
Form and jack marks specific links with white paint.
These are shots, markers that tell the ship's crew exactly how much chain they have let out into the water.
Finally, the hardware, the swivel shackle. This allows the anchor to spin without twisting the chain.
The chain is coiled onto a heavy-duty shipping skid. A mountain of black steel.
The locking pins are hammered in. Once set, they can never vibrate loose.
It weighs over 150,000 pounds. It takes a specialized forklift just to move it to the truck.
From the fire of the forge to the open road. Next stop, the shipyard.
At the shipyard, the chain is fed into the belly of the beast.
Stamped, tagged, and certified. Ready for duty.
The anchor is connected. A 30-ton golden spade ready to dig into the seabed. Then, the moment of truth. The anchor drop.
Gravity takes over. As the chain flies out, the friction is so intense it can create smoke.
Impact. The anchor bites into the floor.
The ship holds fast. The wind pushes, but the chain pulls back.
Steel, fire, water, and sweat.
For Foreman Jack and his team, it's a dirty, hot job.
But for the sailor sleeping soundly below decks, it's peace of mind.
In a world of high-tech missiles and radar, sometimes the most important technology is a heavy piece of steel.
Built in America. Forged to hold the line. This is the strength of the anchor chain. Unbreakable.